more related rates coming at you. Now we're looking at ones with triangles, because those seem to be the ones that happen most often. So in this problem, an airplane flying, we're going to have this as our plane up here, and we're going to say that here is a radio station off in the distance. They want the distance between them to be called S. The plane is flying at an altitude of 6 miles, so that's why that sits right there. And now, what do you know? I have a right triangle that I'm working with here. Go figure, right? Well, anytime I have a right triangle, I need to be thinking probably Pythagorean theorem. So a squared plus b squared is equal to c squared. Or in this case, we're going to say s squared because we're looking at the hypotenuse being called s for some reason. Okay? Now, like we said in the previous video, if you have something that never changes throughout the course of the problem, then it's something that we're going to plug in immediately. Well, let's look at what we got. The plane is flying at 6 miles high, and it's going in this direction at 10, or I'm sorry, not at 10, at 400 miles per hour. And you want to say when S is 10. Well, S being 10, is it always 10? No, it isn't, because as the plane is flying here, S is going to change. When it gets directly above the radar station, it won't be 10 anymore. However, it says it is flying at an elevation of 6 miles. That's not changing. That means I can plug in 6 miles immediately. So I'm going to plug in 6 for A. I still don't know what B is, and I still don't know what S is. But that being there, I can plug it in immediately because it's never changing. Okay? So when I do that, now I can take a derivative. The derivative of 6 squared, or 36, is 0. The derivative of b squared will be 2b, or not 2b, db dt. And on the other side, 2s, ds dt. What do I know for sure now? We said this here, the rate that it's going at 4 miles an hour, that's how b is changing. Well, that would mean psi b is actually decreasing in length. So, I mean, dB dt is actually negative 400 miles per hour. And what else do we need to know? We need to know B. We need to know S. Well, it says when S is 10 miles, but we don't know what B is. Well, again, at that point, though, I have a right triangle. So I can say 6 squared plus what would give me 10 squared. That means it's going to be 64. And that means in the end, the other thing we need, ds dt, that's what they want to know. So that's our unknown. Let's try to solve for it. 2 times b, which is 64. dB dt is negative 400. And then we also have on the other side 2 times 10 times ds dt. From there it's just simplifying, and we're going to end up with, when you divide this 2 times 10, divide by 20, and you'll end up getting negative 500 miles per hour for ds dt. So that's how much it is changing at that point. Again, think about it though. A negative velocity kind of doesn't make much sense, but in terms of how the plane is going with respect to the radar station, right now the distance is getting shorter, so it should make sense of a negative velocity because the distance is also closing on you. Okay? Now the reason I said at the beginning that we could plug this right in, say you didn't realize that, and we went from the beginning with this, and you would have done 2a dA dt plus 2b dB dt would equal 2c, or 2s ds dt. I did it again, s. When you would to try to plug things in for this, you would realize, well, a being its height, dA dt never changes, the elevation never changes, so this term would have gone to 0 anyway, and you would have been left with the exact same equation that you just had. So that's why it's not a big deal if you don't want to plug things in immediately, if you're worried you'll plug the wrong thing in, because you'll end up with the same answer as a result anyway. Let's look at another one. In this new triangle, we're looking at a ladder leaning against a building. So the ladder is 13 feet long, so I'm going to say here's my building, here's my 13-foot ladder. The base of the ladder is being pulled away. So I'm going to try to do the rates here in blue. It's being pulled away at 2.5 feet per second. How fast is the top of the ladder moving down the wall? So we want to know how fast is it moving down the wall when the base is 5 feet, the base being this part right here. So again, we don't know what it is. What is never changing? Well, the ladder height should never change. So a squared plus b squared equals c squared normally, but c will never change. That's always going to be 13 equals a squared plus b squared. I'll say this is b over here, and I'll make the base called a. All right. So take our derivative at this point. 2a dA dt plus 2b dB dt will equal, derivative of our number is nothing, 0. Okay, let's plug in what we know. 2 times, well, at this point, the base is 5, so I'm going to plug in 5 dA dt. How is the how is the base changing? It is being pulled out at 2.5. That means that its length, the length of the base is increasing. That means it should be a positive 2.5. Plus 2 times, what is b? Well, we don't know for sure, but again, if a is equal to 5 at this point, that means that I can find Pythagorean theorem, and 5 squared plus 12 squared gives me 13. So that's going to be 12 here. And dB dt, that's what we don't know. dB dt, we don't know. It's still equal to 0 on the right-hand side. So that means when I do this simplifying, I should have dB dt will equal 2 times 5 times 2.5. That should all be negative because you would have subtracted it over. Divided by 2 times 12, which means my answer in the end, I should get negative 25 over 24 feet per second. That's when the base is 5 feet long. To do it when the base is 8 feet long, well, the only difference is now A is going to be 8, which means that B is going to be some other weird number. It's going to be square root of 13 squared minus 8 squared, which is square root of 169 minus 64, the square root of 105. So other than that, I plug everything in the exact same way. So it would be 2 times A is now 8. The A dt is still the same, 2.5. Excuse me. Plus 2 times B is now the square root of 105 times dB dt. And that's still equal to 0 over here. So when I do that simplifying, I get dB dt will equal 2 times 8 times 2.5, again it should be negative, all over 2 square roots of 105, which will simplify to 16, 20. Should be negative 20 over the square root of 105, and again, feet per second as your answer. So hopefully the triangle ones aren't too much difficulty. Between these, the volume problems, and maybe a couple with similar triangles, that should be all the kinds of problems that you will ever see with related rates. At least if you can think how to set it up, we'll be at least in somewhat good shape as we're going through these. Best of luck.